to thank the council members of Institute of Engineers India, Telangana State Center, for giving me the opportunity to discuss about the significance of non-destructive testing for structural assessment before repair and rehabilitation. So, as we have very short time, I would like to cut short and explain you what is more important in terms of testing and analysis before going for the repair and rehabilitation. So coming to the introduction part, mixed design of concrete, which is the most fundamental part. Today, why we are talking about repair and rehabilitation? Because we are not doing the proper concreting when we have to do. Even today, I can see most of the structures are small structures, G+5 up to G+5. Most of the structures you see in the concrete mixed design, what is being used? We are using cement, we are using coarse aggregate 20 mm, no 10 mm, river sand or crushed sand, water, that's all. Only 4 ingredients are used. But today's day, I can tell you we are building structures which are having more than 10 ingredients. Technology is there, but adaptability is not there. I'll tell you one example, US Consulate Hyderabad, which is recently constructed. I was the person who gave the mixed design for the US Consulate in Hyderabad, which is newly built. In that, we have used 10 ingredients. We have used titanium dioxide for environmental prevention, for deterioration of concrete. So we have a lot of materials, we have a lot of technology, but even when it comes to small scale projects, we are not able to materialize the concrete in a proper way. So I would request, whatever be the size of the structure or the project, it is our basic necessary to maintain proper mixed designs in concrete. And also, I start off with proper geotechnical investigation, testing of water. As our second speaker, Dr. Pantji also has shown us the image of a high-rise building in New Delhi. Now, what is the problem? It is because of the corrosion. Now, from where this corrosion comes? Corrosion comes from the concrete materials itself. So, be it from the cement or be it from the water, especially in the areas, water. We need to test the water. Cost of testing a water in the site for construction purpose will be around 1,500 rupees. That's all. It's very economical, I can say. So anybody can test a water sample before using in your concrete making. Okay. So by taking lot of measures during the construction itself, you can you need not think about repair and rehabilitation. That's what I can say. So coming to the introduction part, increased use of cementitious materials. Now, as fly ash, GGBS, microsilica, metakaolin, many supplementary materials have been used in concrete. But how are we using them? Are we using to the maximum extent or moderate extent, and how is the concrete being produced? That is also one of the important things. Decline in the standards of workmanship, bad construction supervision, and I can also say laboratory tests on material will reflect only the adequacy of the materials, but in situ strength is not reflected. You cast hundreds and thousands of cubic meters of concrete in the site, but how many cubes you are testing? These testings of the laboratory material will give you only the cube strength, but not the actual site strength. So to know the in situ strength, we have to evaluate by using the methods called non-destructive testing, NDT. Okay. So to ascertain the quality of any structural component or a structure as a whole, and what does this indicate? These indicate the magnitude of defects, extent of distress, quality of work, conformity to standards, and conformity to specifications. So what are the aims of doing this in situ testing? Why is that we need this in situ testing? So proposed change of usage or extension of structure. In the morning session, Surprakash sir has already told us extension of structures. Hotels are being enhanced into hospitals. So whenever there is a change of usage or extension of a structure, we need to do the NDT. I'll tell you one small case study. Recently, it's a 6th-floor building in Himayat Nagar. And the doctor, he's a doctor, he runs a diagnostic center. He has a 18-ton loaded MRI machine in the ground floor. Now, because of the increase in the demand, he wanted to put additional MRI machine in the 2nd floor. And the building is a 40-year-old structure. Can we simply say you can put it? No, we can't say. So for that, what we need to do is we need to assess the building. As Ganesh Babu sir said, preliminary inspection is the first important thing, and then the NDT evaluation. So we have done the NDT evaluation. We have, if the drawings are not available, we made a structural model, and then in the second floor where they are proposing the MRI, we have put the new MRI loadings and we have verified. And in our analysis, we found out 2 columns were showing deficiency. Those 2 columns we have given the restoration scheme. Now that is done, new MRI is installed. Cost of MRI is around 15 crore rupees, and it is airlifted from Germany. You cannot simply, without assessing the building, even these suppliers will tell, please ensure the building capability. So proposed change and usage of structure, we have to conduct non-destructive testing, acceptability of structure for purchase or insurance, and assessment of structural integrity or safety due to material deterioration. Now, recently we also we have seen many projects because of the fire, they have been deteriorated. And the major reason for fire in these buildings are, I can say, waterproofing again. Not doing proper waterproofing, the water getting contact with the electricity, they causing short circuits and lot of fire inside the structure. Now we all know there is a problem, the fire damage is there. To what damage it is there? How you assessment? Not just by NDT. NDT will give you the homogeneity of the structure even after fire, but what is the remaining life of the concrete in the structure can be assessed by doing some laboratory tests. We will collect hardened concrete samples from the fire damaged portion, and we will assess to what degree the fire has been exposed to. See, fire may be from 500 degrees to 1000 degrees also. We cannot directly see while the fire incident happened. So we will collect the samples from the site, and we will assess what is the extent of damage. That means what is the degree of fire the concrete was exposed to. And we will also collect the samples, and we will check the density of concrete. What is the density of the concrete, remaining density. So by doing this specialized test, we will come to know what is the remaining life of the structure and how to restore it. Okay, and there are many other advantages also. I'll brief you. This is a non-destructive testing part when it comes to the structure as a whole. Non-destructive testing, destructive testing. Generally, destructive testing is done for the precast elements, up to its failure load. And semi-destructive comes like, extraction of concrete cores for compressive strength and other things, and some special test as well. So NDT means testing of structural members without destruction or damage. Semi-destructive means testing of structural members without affecting the structural integrity. And destructive testing means up to its failure, testing up to its failure. So major test, rebound hammer test, ultrasonic pulse velocity test, cover meter test. You can measure the cover of concrete, and you can also detect the diameter of the first level of reinforcement in the concrete also using this. And half cell potential measurement test. You can understand the corrosion activity in the reinforcing steel, and then the carbonation test. Now how do we do this test? For all these tests we have prescribed standards. You can have reference standards starting from UPV test, rebound hammer test. IS 516 is the code. It is split into many parts and sections. And then cover meter study, carbonation test, and the corrosion assessments. So I just show you the photographs of this rebound hammer test. You can do it in many directions. Horizontal is the best preferred way. You can see this is the position of rebound hammer vertically upwards. This is position of rebound hammer vertically downwards. And this is the ideal position, I can say, position of rebound hammer in the horizontal method. So I see most of the projects, without chipping the plastering, rebound hammer has to be should not be done. Only the concrete element only has to be tested. Okay. There are some correction factors. When you see, it is based on the instrument manual. We have many manufacturers in the industry. So whatever instrument you are using, you have to apply the respective correction factors which is given in the instrument manual. Okay. There are some factors affecting the rebound hammer. Type of aggregate, age of concrete. Your minimum age for testing NDT is 14 days. Once the concrete is cast in the structure, after 14 days only you are supposed to do the NDT. So surface condition. Ensure your concrete is dry, it's not damp when you are doing this NDT. Okay. Preparation of concrete test surface, curing, carbonation. These have to be remembered. Now, and one more thing, we see many rebound hammers available in the industry. But how do you ensure whether we are using the proper rebound hammer or not? You need to calibrate rebound hammer on an anvil. There is a material called anvil. On that you have to strike the rebound hammer, and what is the number displayed on the anvil should be displayed on the instrument. Then only the rebound hammer is said to be calibrated. So these are some tips I can say before going to the test. And you have to clean the surface of the concrete using a carborundum stone so that the surface is smooth for taking the test. This is ultrasonic pulse velocity test. So you can see how the UPV test is done. You can do it in the opposite phases. Direct method, indirect method, and semi-direct method. I'll show you the photographs so that it will be very easy for you to understand. This is a direct transmission of ultrasonic pulse velocity test in the beams and columns. Okay, and this is semi-directive test. So there are some grading charts given for the ultrasonic pulse velocity test based on the grade of concrete. If the UPV value is greater than 4.5, then the concrete is said to be in excellent condition. And there are some factors, reinforcing bars. I'll share this presentation. I hope IEI will share this presentation to you all. So this is some tips. You can also estimate the depth of the crack using ultrasonic pulse velocity. Transmitter and receiver are placed away from the crack, and the pulse velocity is recorded in the first this. And in the second time, what we do is the transmitter and receiver are placed as such a way that the crack is at the center. In this case, the pulse velocity will be higher. Okay, so then you have a formula. You can substitute the values and you can estimate what is the depth of the crack. So this also can be done using the ultrasonic test. This is cover meter test. I can say this is a calibration block for profometer, and you can scan the bars inside the columns and beams. Okay, you can measure the cover and you can identify the diameter of the bars as well. So there are some limitations. Corrosion. Now, if I talk about corrosion, 40% of the steel manufactured in India every year is used to replace the corroded bars. 40% of the steel manufactured in India is used to replace the corroded bars. Now, this corrosion mainly, when the concrete is cast, it is having high alkaline nature. It is around pH value is around 13 to 14. When the concrete is not protected, then there is a term called carbonation which happens, and then corrosion is into picture. And it is we are having some damage stages also. I'll just show you. Now, how do you measure the carbonation? You can chip the surface concrete and spray a phenolphthalein solution and see the change of the color in the concrete. If the concrete changes its color into red purple within 30 seconds, then concrete is good. It's not carbonated. If there is no change in the color, then it's said to be carbonated. Then you have to do the concrete petrography to understand the further problems. Okay, and half cell potential, this is the last test I can share. This is to assess the corrosion in the reinforcement steel. You can see more negative than minus 350 millivolts indicates high probability of active corrosion. And readings below 200 millivolts indicate less corrosion. So this is one case study I just wanted to show you. This is one ammonia sulfate processing unit which is in a coastal area in our country. The problem was the sulfate expansion in the building caused lot of deterioration. It made the concrete surface look weak and soft. So we have given the restoration scheme. Now it is standing safe. Now coming to the damage stages, first stage is formation of white patches. Second stage, change of color of the patch. Third stage, development of hairline cracks. Now that is where your maintenance activity has to be taken care. And then if not, multiplication of cracks and widening of cracks. You have the access for the oxygen and moisture, and then spalling of cover concrete and snapping of ties. So then the final stage is bulging of concrete. So with this, I think I'll end my presentation.